Alright, so here's number 2. We're doing, there's 4. We're doing like a whole series thing.
There's more?
Can you just reveal the answer to
Me too. Kind of
It's been a while since I've been volume this one.
Yeah, pretty much.
I need a little refresher.
Alright, here's revealing the answer for volume.
Oh my god. I can't do it.
It's 0.4 inches per hour.
Joe was been on sneezing.
0.4x.
Good, Joe Will.
Then x would be the amount of hours.
Alright,
Fine.
so volume
Oh.
is
Plus
rate
the volume.
times width
Okay.
times height. So yeah, number 1, the volume would be 10 times 7 times h, but this one is a bit of a unit trick, and we do this, but this says to do volume in inches and it giving you feet.
Oh my god.
Oh, brother. Being tricky.
So that's so annoying. So really, 10 feet is how many inches?
Well, I don't even know.
120.
Or I mean, well,
And then 7 feet is how many?
I don't know. I
800.
couldn't tell you.
So our volume would be
120 times 84h.
What the freak?
84.
It's 7 times 12.
7 times 12,
840.
84. 7 times 12? Bro,
That's
yours
7
okay?
no, she said.
What you trying to do? I literally got it. I literally got it, don't play.
Oh, I thought you said.
Oh, 120. Wait, no, shut up.
Boy, get out of my house.
I got the answer.
Ava got the answer.
Oh my god, I got it.
1080.
2080.
What?
70 feet.
Oh my god.
7 feet is not 840 inches.
Well, she's like doing some whole calculation over there. Like, just let's put them together.
70 feet is 840 inches, but 7 feet is 84.
Oh, because you're.
Bro, come on.
I did 70.
Okay, what are you guys doing?
I like what you're saying now. That is crazy.
I like that idea.
I'm confused what we're doing anyway.
How would Charles Jones
Oh my god.
It's 70 feet.
He literally married his cousin and had kids with his cousin.
Ew. Okay, you know what? Now
I know
Is that why you like Alabama's in there?
I just said that, Jaden.
Oh, calm down.
The family orb. Do you guys remember Wubble Bubble Balls?
Oh my god, I never had one. I wanted one.
Yes.
70 times.
And if you order it in the next 20 minutes,
Oh, I love
you
that.
get
840
double
times
that
12
and you get
would
one
be
for
your
free.
answer. Yeah, one
Oh, those are
for free
fire.
and one for free.
Maybe, but like I
It's
don't
about
exactly
30 cents
know.
in
Like
value.
sometimes 10,
Because it's all made in
70,
China.
70 times 12
Buy
is
it.
840.
Yeah,
Times
it was
12
for-
again.
Like, don't we just-
I'll get like a half.
Don't we just multiply them together? Like,
Snackies.
oh my god, I have one of those too. I have it.
I have one. And then,
Oh my god.
See, I said it. Only today. Where are you doing?
840. We do 70 times.
We're doing 70 from.
The 10 times 7. And then
don't know why in this very moment that conversion isn't working, but I'm gonna just get on it right now. So the basin is 120 inches wide and the it's 84 inches long. So the volume is 120 times 84, which we decided is what?
It's 10,080.
That's what I said.
2 inches higher.
You were right.
Davis.
Bro, we literally got it right. We said what that we said. Like, I think of it. 10 hours ago.
Yeah, that's it. About 0, 0, 1. I just.
10,080. All right. So and then number 2, the rainy season, it says it rains 0.4 inches each hour. Write an equation for the rate of rainfall each hour. So it rains 0.4. I was gonna put H here for hours, but that's kind of confusing because H is already height, so I'm using 2 for time. All right, number 3. Use composition chart function that expresses the volume of water in the basin as a function of the rain time in hours.
What?
So composition's a little bit more than yesterday, putting one thing into the other. I'm gonna give you guys a hint.
Oh, rain date.
The rain height
Girl.
is 0.4 times 2.
So would you would plug that into the other thingy?
Oh, so we were talking.
I was literally thinking that.
So I would need to tell at least
Oh, I know
5 people have it written on paper before I do it. That's what I did last time.
Okay.
And I got 5 people just by walking through 2 rows that had it done.
What's one?
Anyways.
Next one.
You got it.
Is that right? Oh my gosh, you're so
High
smart.
five.
I don't even know what to do.
Yeah, I don't know what to do with black shoes.
I'm letting you go here.
So what? I was saying that you were talking about how it was normal for people to do that. So I was saying
What's up? Like, oh my god, I'm so sick of you guys.
It would look better. No, it looks better if it was white socks.
oh wait, she does not need
I don't like white
socks.
socks. What? I don't like white socks.
Yeah, but black looks better.
Oh, okay.
I was thinking if you would have worn white socks, it would look better.
Because they're gross.
No,
I have 6.
I like white socks, but like
I got 6 exactly, guys. I have 8.
it just depends on how you wear them
I
and
don't
how
know
far
white
you
socks,
fold
so I
them
don't
out.
wear them. Yeah. Whatever.
I did it at 10,080 and then within parentheses 0.14.
Hey, Caleb.
Oh, that's drip.
Huh?
That's drip.
Have you guys ever been to Japan?
Huh?
Yes.
Yeah.
That's crazy.
Have you?
No.
Wait, what's happening?
I asked if they could get me.
I
But
never
for
seen
you,
it.
Steven doesn't like this.
What the? Steven's goofy. I didn't. No, I'm anyways,
Avery, you have your
Steven is an NBC.
I know.
What'd you say?
It's just
Let's go.
I got it right too. Oh, shut up. I got it right. I'm done.
Alright, so composition of functions, you plug one thing into the other. So we're talking about the amount of water in the basin, so it fills up based on like how much rain, right? So the height of the rain in the basin, we would know by just plugging in 0.4 times the number of hours it rains. So that's the composition, is we're plugging this function into the volume function.
Would there be a limit then? Because like it has to over.
It's number 5.
Oh my god.
I'm too good.
Yeah, that was really good. Okay. Alright, so the volume is a function of rain over time. So now our volume is a function of rain over time, and that would be the length times the width times 0.4 inches each hour, and that would be the volume of rain in the basin. And who actually multiplied this? You got a number?
No, me not.
4,032.
4,032.
So our volume as a function of rain over time is 4,032 cubic inches times the number of hours it rains. So this composition often would take a standard formula, like length times width times height, that is just kind of concrete and static and not moving or changing over time. And they you put a rate in there, whether the length is changing for whatever reason, or the width. And here it's rain height, but they use this a lot of times for like if something is inflating and deflating, and that's changing another object that it's a part of, like maybe the buoyancy of a raft and how much air is in it, and the rate of time it takes for the air to go in.
Or crucial.
So composition takes something that's like still, and you put a rate in there, and it makes it something useful. So find the volume of water in the rain basin after 8 hours of rainfall. So particularly if this is like a rain basin that's difficult to get to, whether it's underground or for whatever reason, if you're a farmer,
I'm not.
this is your rain basin. You know it's been raining good for 8 hours. You're wondering how much rain you have collected to water your crops or whatever. This 4,032 times the number of hours it's been raining, and you have an estimate of how much water is in your basin that you can use.
We have 32,256 something of water.
And so now in my notation, I can put 8 in here for hours. Please say it one more time.
32,256. Is that like gallons or liters?
It's actually
Inches?
this is cubed. Cubed inches because it's volume.
So would we divide that by 12 to see how many square feet? Cubed feet?
It doesn't say what.
Yeah, dividing it by 12, I guess would be square feet.
It's 2,688.
Number 5. Use symbols to show the maximum height in rain basin is 20 feet. And this is, I believe, the limit you mentioned, Natalie. Of course, this rain basin doesn't go on forever. So at some point, it's overflowing. So at some point, the farmer can no longer put hours in it and say that they're still getting more and more rain stored. So at some point, there's a limit. How do we show a limit with symbols?
This Baldwin is a farmer.
Did you plug the 20 into the R?
I was going to use H. I was going to put H for number 1. I'm going to say that H is less than or equal to 20. Well, the height of the water can't go over 20.
Yeah.
Well, we got to put it in inches, though, don't we? What's 20 times 12?
240. Wait, someone just had to erase that, Ms. Baldwin.
So,
Yeah, I am using
the
that.
height of the rain, oh my god, will only we no longer can perform a volume function because this pull-up doesn't have a volume in it. So the volume would be the rings, while the height is the domain.
Well, also like when you fill something out, I mean, like when you fill something, normally there's like a little bubble on top. So I think I can go a little bit over 20.
Oh my God, no.
Surface tension. Yeah. That's the word for that. Plus that surface tension.
Like when we do the penny drops.
The pen drop surface tension. You wanna look at that formula?
Actually, no. I think I might pass on that one until I get to ace math.
When did you guys talk about surface tension?
Like every single grade since like 6th grade, because we've had to do that stupid penny drop.
Oh my God.
Every single year, miss.
I've got the drops on a penny still.
Oh yeah.
Did that for the first time this week.
What do you have? Yeah. Never did that. What do you have? We did it in her class.
Probably.
Alright, here's your answers for the Congo.
Oh, you just revealed the answer.
Spoiler alert. Spoiler alert. Here's the answers for the Congo. I was looking at, did I look up chicken tahine in here?
Chicken fried.
And fish fry and Popeye pie. I looked it
No.
up.
Miss, can you look it up for us?
I looked up where the capital city was born at.
And you found it?
And I found Republic of Congo just to make sure I what the language
I didn't even find it.
I already knew that.
Actually, there was a student this year who figured it out.
I figured it out
Figure what
yesterday,
out?
Miss
They
Baldwin.
did it without any Google. They knew like there was like 7 countries in Africa that spoke French
Because of.
from imperialism.
I was just about to say that, Miss Baldwin.
And they narrowed it down by size and GDP.
Who was it? Name drop. Logan Max.
Oh my gosh. Wait, who?
Logan Max. Ben goes crazy for history.
Oh, that was us.
Oh. It was very cool. He was like,
Of course he knows stuff like that. Got like a 90 on the ACE exam.
I didn't know that.
yeah, Miss, he really likes history.
Yeah.
He goes crazy for it.
And English and all that.
So you want me to calm down?
Did you fall asleep during this one?
I was doing bio and math and another class.
Not like it was a final exam. We like took the ACE class exam. The exam in the
Oh, the midterm.
Oh,
yeah.
You got 90 on that?
Yeah.
I got 85.
I was confused for a second. I'm like,
No, not the actual
Wait.
exam.
I was not sleeping. I was working on everything.
You want to show me the game? At the beginning I was watching and then I just started playing music, so I just went. Yeah, she was like, pretend that you're watching. Make good acting.
It's my front and my back. And my work's over here.
Oh, I need my
Oh, Miss
workout.
Baldwin.
What? Wait, do I need to show my work?
I am looking at where.
Oh, wait.
So here's the last 3 French was
Somewhere back here. Here.
This is work here.
Oh, well, yeah, but the front I did right here. Literally, that.
Are they at least he's
Oh, yeah. Thank goodness.
He's too tired.
I wish Natalie could obviously, but like when
Roll
you're
his ankle, I guess. Hopefully not. That would be my phone. Oh, okay. Hopefully you run your car off the highway.
that was a really how sweet of you.
I'm joking. If I wouldn't say it to anybody except for you.
Did I show pictures of his country?
Is that World Cup?
Yeah.
Oh my god.
These are such scenic. Oh,
World
Cup!
Cup.
I was thinking maybe it was rugby because don't they also play rugby in Africa?
Don't they? It's not messy.
So we don't know if this is nobody can tell me what the rugby field looks like.
Miss, I've seen people play rugby.
I've never seen play rugby.
That might have been a city.
Rugby
It's
is scary.
It's a big sport in like Australia and Canada.
What? Yeah, it was over in Seattle. So it's probably.
Natalie.
Well, that's so cool. It's like an anaconda. Oh, the Skyway Bridge. I can see your car. Oh, look, they've got mansions next to it, miss.
How is our suspension bridge different from this one in Africa?
Our pole's
Theirs is
light up.
floating.
Their poles.
Yours is under land. Ours is
They don't have. It's on the outside, miss.
They're using 2 rows of poles.
And
Ours go in the middle. Which one do you think is stronger, our suspension bridge or their suspension bridge?
their suspension bridge.
Actually, I don't know.
I think ours is way higher.
Yeah, that's true. Theirs is kind of short.
Wait.
I don't know, like our cruise ships that go under there, aren't they like 4 stories high?
Well, I think
Probably.
it's taller than 4 stories because the story's only 10 feet.
A cruise ship. They look huge. Have you guys seen the cruise ship?
Yeah, that's what I'm saying. It's taller than 4 stories.
That's how they go.
Mama Africa. Look at the profile
Shakira?
You're like, no.
Wait, miss, can you look up the pies and stuff? What?
We need to see that fish pie.
Yeah.
Oh, fish pie. Or paw paw pie.
Alright, today we're going to talk about inverse functions. So we're transitioning from a proposition of functions to inverse functions. So we went from adding, subtracting, multiplying, dividing, to composition, and now we're doing inverse. I'm going to have you writing steps down if you want to just title it. So I put the whole section number here. It's 501 to 513. The whole section's on inverse functions. Inverse means like perfectly opposite. So we're talking about perfectly opposite functions. And you don't have to write this on the board here, but this is the concept.
Please tell me about the ground.
So inverse functions are perfect opposites. They are proven through doing composition, f of g of x and g of f of x. So that's why that section makes it is. We don't do proofs in algebra 2, really. But you do proofs in geometry, right? This is a proof that you would have to do in pre-calculus, most likely. You prove inverse. In a proof, you show properties and all that. So for example, x to the third is the perfect inverse of the cube root of x. Those are perfectly opposites. And to prove it, I do composition. So if I put g into f, I take this one and I put it here, the cube root and the exponent cancel, and you just get x. So those are perfectly opposite because the operations disappear. They cancel each other out. And you have to go the other way to truly prove it. You have to put f into g. So if I put x to the third into g, the index and the exponent cancel, and you just have x. This shows perfect inverse. So you can prove it through composition. But writing inverse can be more difficult than that. Like I have this memorized. I know the inverse of x to the third is the cube root of x. But for more complicated equations, I don't have it memorized. I don't know what the inverse is. So there's steps to finding inverse. Here they are. Let me erase a little bit on here. So these are the steps that you're going to use for your assignment today. Steps for finding inverse. If you don't know the inverse of an equation, this is how you find it. First off, you're going to be given a function called f. Start out by writing your equation. Instead of the f of x, put a y in. Which you do naturally, probably. Anyway, you know that f of x is the same as y. Step 2 is really where the inverse happens. You switch x and y. So the real definition of inverse, instead of just saying they're perfect opposites, is that the independent variable and the dependent variable switch. So inverse really means that input and output switch. So number 2 is the real objective, just switch x and y. Number 3 is where the real work comes in. After you switch x and y, you have to rearrange the whole thing so y is alone. And then number 4, once you're done, is just showing it correctly. If you're told that the original is called f of x, the inverse you show with a little negative 1. This isn't like, now I have to do math with that. It's not an exponent. This is a symbol that means inverse. So this is how we know which came first. This is the original. The one with the little negative 1 is the inverse. Okay. So I'm going to jump right into your assignment, page 509. I'm going to do number 9 right now. Just put that right in the trash cylinder. So everything here is linear. So here's number 9.
Wait, no one said hey to you.
Alright, so here's step 1. I switched from f of x to y. That was it. Okay. And here's step 2. You switch x and y. That's actually the inverse. Switching the x and the y. And here's step 3. You have to do the work to get y alone. So I see y here. I'm rearranging this equation. So I'll divide both sides by 6.
Oh, so that makes sense because there's no like y-intercept. It's just
Yeah.
and it's just this stuff.
Right. So this is done here really. X over 6 equals y. Y is by itself. That's the inverse. But we're going to graph this. So graphing a fraction coefficient is more useful because this is linear. It's slope. It's rise over run. So instead of x over 6, I'm just writing 1/6x, which is equivalent. And the very last step is to use the proper function notation. So I started with regular f of x, and my result is f negative 1x, and that really just means, well, this is the inverse. Okay. So had somebody asked me inverse before I ever was taught it, I probably would have guessed negative 6x, like opposite, right? But actually, the opposite of multiplying by 6 is dividing by 6. We're looking at a fraction. It's opposite operations. So the inverse of 6x is 1/6x. So then you have to graph them both. Because there's a pattern when you graph inverses. So the whole entire assignment goes back to graphing straight lines. y equals mx plus b, a little review, slopes and intercepts. You're always supposed to begin a straight line at the b value, at the y-intercept. With this equation, there's a 0 here. So you start at the origin. And then your rise over run is up 6 over 1. Up 6 over 1. Straight line graph. So you have to graph both. You have to graph the original and you have to graph its inverse. So the inverse is the same thing. You start at 0, but you go up 1 over 6. Up 1 over 6. If you have graph paper, I suggest you use it. You'll actually get this done more quickly on graph paper than on those little things you got there. I think. Unless you really are used to the way the book has it shown. You have to graph every problem. And on every problem, there's 2 lines to graph, so. Alright, so I'm going to indicate on my graph what was the original and what is the inverse. So those 2 things are perfect opposites. And that's the whole lesson. That's it. There you go. Go to the next one.